It is no fun to be trying to have a conversation when you've got a 2-year-old screaming right next to you, right? It ends up with just a whole lot of noise conflict. And the same thing can happen when we have different access points that are conflicting with each other. If you have two access points and they are using the same channel, well, we know that there's going to be a lot of noise conflict. What's going to happen? Well, literally, as they communicate back and forth to each other, that communication is heard and recognized, and the actual packets are going to be decoded by the access point. It's going to read them and say, oh, this is an intelligent packet from an access point. It's in my area. I'm hearing its noise, therefore I should wait. So even though it might have a completely different SSID, even if it's just one off in its channel, but notice it's a part of an overlapping range that enables most of the packet to be heard and deciphered, which again, remember our various different chipping codes enable you to read stuff, even if not all the bits get there. And so it will wait. You see, it's essentially like adding a noisy client. It's like adding a noisy 2-year-old when you have a overlapping channel or the same channel being used by different access points, because it says, oh, I can't talk as long as you're talking. I'll wait for you to be done. Wireless uses a methodology called CSMA-CA to determine when not to speak and when to speak on the network. And so an access point that is in the same or in an overlapping channel is going to create essentially a whole lot of weight in the process of communication. Not a good thing. So in the 2.4 gigahertz range, what we could do to avoid that would be to choose channels within that 2.4 gigahertz range that do not overlap. So we have 22 megahertz channels, and it turns out that channels 1, 6, and 11 are beautiful. They do not conflict with each other. Remember, we can go all the way up to channel 11, up to channel 13 in Europe, up to channel 14 in Japan, but even channel 14 has some overlap with channel 11. If I was in Japan, though, I might use that as an optional fourth channel, all right, but Japan only. That's the 2.4 gigahertz range. That's best practices, all right, so that we end up essentially having two conversations occurring side by side, like me talking to you. Meanwhile, there's somebody blowing a dog whistle with Fido right next there. It's not a problem, right? Because the dog whistle communication is happening at one frequency. I'm at another frequency. No conflict. Can we do the same thing at the 5 gigahertz range? Is it an issue? Well, it is an issue, but less so. The way that the channels are spaced at the 5 gigahertz range, and because of the power drop-off, the no power zone that we see here, there's a whole lot less overlap. It is technically possible because of the core strength of signal being there in the middle portion of the band to actually occupy adjacent channels. So you could use channel 36 and I could use channel 40. But there is some conflict. It is not good, all right? It's not going to help anything to use adjacent channels. But we only have to be one off. But notice that the channel IDs are already organized in blocks of 4. So adjacent channels would be 36 and 40. Channels that are separated with one channel will be channel IDs that are 8 in separation, all right? So separation by 8 is the magic number there. So what we're seeing here is actually the UNI 1 band. Remember UNII, that was specified by the FCC. So these are the UNI bands. This is the low band, indoor only. Here's the UNI 2 band, also for indoor only. Then we get to the UNI 2 extended band, and that's going to keep on going. So we start here and we keep on going. Here's all those frequencies and the channel ID numbers. Here's the end of 2 extended. That's indoor or outdoor, limited outdoor use. And here's the upper band, the outdoor only, which again, remember the European standard does not support that. ETSI does not support UNI 3, but in the United States, the FCC is okay with it. Okay, so again, if I was in the United States, FCC supports it, I want to use it. I need a couple of different access points. They are going to be proximal to each other enough where they could potentially hear each other. If they're close enough to hear each other, then I would want to select channel IDs just like this. Remember, when it comes to applying these, let's go back to the 2.4 example. If I've got access points configured and they're going to overlap with each other and I want to be able to roam, This one would choose 1. This one could choose 6. Oh, but I want more support. Okay, well, this one does 11. I want more. Okay, well, then this one's going to support 1 again. And then this one can support 6. And then this one can support 11. And then this one can support 1. See, I can just keep growing these out as far as I need to based upon this type of expectation of overlap in order to create the ability to support all the different networks. And so I can grow and add more and more access points and roam through all of them. They all have the same SSID, but they have different channels, allowing them to be recognized as distinct, and they're not going to conflict with each other because they are in a separate frequency headspace.